Hello, in this video, we're going to move on to the second scenario to calculate the confidence interval for mean. As you know, when we have the data set, we might only give a sample data. We will never know our population sigma. So if that's the case, are we still able to figure out what is the confidence interval for my population mean? The answer is yes. So instead of using consider our data is following normal distribution, and we believe our data is called a student t distribution. And I'm going to explain briefly about our student t distribution here. Okay, so before we look at the student t distribution, and I want to talking about that formula we use to calculate confidence interval for the mean, how we will need to change if sigma is unknown. So if we only have the sample data, we only can calculate S, which is our sample variance, sample standard deviation, instead of our population standard deviation. If that's the case, we need to converting our formula to the following. So X bar is still the same, X plus, instead of use the Z statistic, we're using the T statistic now. And then times S instead of sigma, because we don't know sigma, we are using the estimated sample standard deviation. And then still divide by square root of the n. Okay, so for S divided by square root of the n, we instead of call this standard error of the mean, we call it estimated standard error of the mean. Okay, estimated standard error of the mean, because our S we are using the S instead of sigma, and S is estimated standard deviation. So therefore, we consider this as estimated the standard error of the mean. Okay, so that's the only change. So far, think about how many formula we learned, right? In general, we learned three formula. The first one is how to calculate the standard error of the mean, right? And then the second, we learn the range of the mean. The third is the confidence interval of the population mu when sigma is known. And now this is the fourth one, is the confidence interval for the mean mu when the sigma is unknown. Okay, so now let me spend a little bit of time to explaining our student t distribution and why we're using student t instead of using the normal distribution. Okay, as you can see on the three diagram below, and we're looking at the sample size changes, how the student t distribution look different from the standard normal distribution. Okay, for our student t distribution, look very similar as our standard normal distribution. And student t is symmetric. Student t is bell-shaped. And you can see as our sample size is increasing, our student t does look like our standard normal distribution. Okay, so what is the main difference between student t versus the normal distribution? And we need to focus on the tail section. Okay, so the tail section. So let me put a vertical line here so you will see what do I mean by the tail section. Okay, as I said, student t is symmetric, just like our normal distribution. The main difference is at the tail section. As you can see, for our red line, that is for student t, and the blue line is for the standard normal. As we get into this -2 area, we still have a lot of area for the red curve are falling to the value smaller than -2 and the larger than -2. And you can go to -3 as well. So that means student t are including more uncertainties or more variation than our standard normal distribution. So does that make sense for you to let's make a sense why we are calculating the confidence interval for the mean when we unknown we need to use student t. So when we don't know the population standard deviation, instead you are using the sample standard deviation, that means we are introducing more uncertainty for our calculation, right? We are introducing more uncertainty. How can we reflecting that uncertainty? So instead of using the standard normal, which has less variability at the tail, we are introducing the standard student t distribution where we are including more variation in the tail. That just reflecting the fact that at this point, since we don't know our population standard deviation, we have to use the estimated value. That estimated value will carry some kind of error. So therefore, our estimate is no longer that kind of accurate. So we are using the student t to capturing that variation from our estimate of our standard errors, right? So therefore, hopefully this explanation help you to understand why we need to switch from z-score to the t statistic. So it's really because since we are estimating our standard population standard error here, we are introducing more uncertainty or variation. We need to use in the t distribution where have a fatter tail, where capture more variation to reflect that fact. Okay, so therefore we are using student t. So here we want to talk about degree of freedom because for the student t, the t statistic, it does not like the z-score. It's very easy to remember. We have 3 values. And of course, you can remember t value as well. But we do want a student to use Excel to calculate the t statistic value. But in order to understand, hey, what we need to put in that t statistics we're going to use on Excel, you need to know the component in that t statistics. So in order to use the Excel to calculate the t statistic value, you first need to know what is my degree of freedom. Okay, so the degree of freedom, knowing the sample size allow us to calculate the parameter called degree of freedom, sometimes abbreviated as a DF. So the degree of freedom, for a large degree of freedom, the t distribution approaches the shape of normal distribution. However, in the small sample, the difference is very important. Okay, so therefore, the degree of freedom here is equal to n minus 1. So why we lose one level of degree of freedom? It is because we are using my sample data to calculate my S value, which is the sample standard deviation. So we lose a degree of freedom. Therefore, we are using n minus 1. So that n minus 1 is the value for degree of freedom you will use, called degree of freedom we're going to use in our t statistic calculation on Excel. So remember, DF, degree of freedom for the t statistic, equal to n minus 1. Okay, as I said, Z and T will be approached when the sample size is large enough. So for the small sample size, the T value will be very different from the Z values. So for instance, n equal to 31, and degree of freedom, it will be equal to 30. So for 90% confidence interval, we would use T equal to 1.697. So that is very slightly larger than the Z-score, 1.645. Okay, but if you're reducing that sample size 30 to 10, and you will be able to see the difference. And later when we look at a computer skill lecture, we will play around a little bit about the n size to show you the differences between the Z-score and the T statistics. Okay, let's look at example together to learn how can we apply the formula we just saw to calculate confidence interval for mu when we don't know the population standard deviation. Consider a random sample of the GMAT score submitted by 20 applicants to an MBA program. As we know, the total applicant who take a GMAT should be more than 20. So we just randomly select this 20 applicants. So this is my sample data. So now, based on my sample data, we want to construct a 90% confidence interval for the mean GMAT score for all MBA applicants. So based on the sample data, we try to understand my population. So first of all, given the data we have, we use the knowledge we have from chapter 4. We use the Excel formula. We are able to calculate sample mean, which is equal to average, and you select all your data, and you get 510. That is the sample mean. And for the sample standard deviation, we use STDEV.S, right? That is the formula we learned from chapter 4. And so we are able to obtain the sample standard deviation here is equal to 73.77. Okay, so given this two information, and we know our sample size equal n equal to 20, and then we're gonna using our formula, which is this. So we know x bar and s and the n. Now we need to calculate the t statistic value, and then we are able to apply this formula to calculate a 90% confidence interval for my population mean, right? So since our population size equal to 20, and then the degree of freedom we needed to calculate student t is equal to n minus 1, we are able to obtain equal to 19. Okay, so when we are using the Excel formula on the Excel, the formula we're using is called the t.inv.two-tails. So we're looking for the two tails. So in this formula, we need a two value. The first value is the value for your confidence coefficient. which is 1 minus the confidence level, right? So 1 minus 0.9 give you 0.1, right? So that's the alpha's value, 0.1. And then the second value here, I'm missing instead of the full mark here, I need to make a change. And then after 0.1, type in comma. And then the second entry here would be the degree freedom. So it's 19. And you are able to find this t statistic value equal to 1.729. Okay, again, we don't use the t table, kind of slow. We just directly use Excel. It will help us to calculate this t statistic we are using to calculate the confidence interval for when we don't know the sigma. Okay, after that, what we're going to do is we're going to apply the formula we already learned. And so the mean we already calculated, and the t statistic we just calculated, and then the numerator is my standard deviation. It's the standard deviation S equal to 73.77. And then we further calculate. So when I pick the chose the minus sign, I get my lower limit. If I choose my plus sign, I get my upper limit. So therefore, the 90% confidence interval for this scenario is between 481. The student scored within 481 to 538. So if we wanted a narrower interview, what we're gonna do is just like with the same level of the confidence, what we have to do is just enlarge the sample size. So if we enlarge the sample size, and we'll make this the interval much narrower. Okay. So this is the example to help you understand how to apply that formula to calculate the confidence interval. Okay, so as we just talking about the confidence width, right? So the question is, the confidence interval width will reflect the sample size. As we said, the larger the sample size, the narrower the interval. And the also the interval level, confidence level, right? So if you have a 90% confidence interval, if you have 90% confidence, that will be wider than your it will be narrower than your 99% confidence levels, right? Intervals. And then the other one is the standard deviation, and the larger the standard deviation, the wider of your interval, the smaller the standard deviation, the narrower of your interval. So again, to obtain a narrow interval or more precision, so the narrower, the more precision, you just need to increase in the sample size and or lower the confidence level. Okay, lower the confidence level from 90% to 80%. So they all gonna be able to narrow your interval. Okay, so more about the student t-distribution. Like I said, you will have more calculation involved on Excel. So the t-distribution assume a normal population. While this assumption is often in doubt, simulation studies have shown that confidence interval using the student t are reliable as long as the population is not badly skewed, and if the sample size is not too small. And so the second question is, can I ever use a z instead of t? The answer is if the sample size is large, z and the t will give you a very similar result. I already shown you like 30. When you sample size slightly larger than 30, you will notice that the t and the z's value are not that different. But a conservative statistician always use the t-distribution for confidence intervals when sigma is unknown, because using z would underestimate the marginal error. The reason we are using t, because it's really reflecting the fact that you don't know the population standard deviation, you estimate it. So if your standard deviation is estimated, it will be some kind of uncertainty involved. So therefore, we want to use the t. So because the t table are, I think we want to, instead of using t table in this class, I wanted you guys using the Excel to get in your t values. Okay, so that is the end of the part 1 learning. In part 2, we're going to focus on the other part, which is the confidence interval for proportion, and also how to figure out what is the right size of the sample.